Whenever we use an electrical device that's not plugged into the wall, we have to put a battery in it. But how exactly does this tiny little cylinder allow technology to function? To understand this, first we need to do a quick refresher course on what electricity is. Now, to keep things very simple here, think of an electron as a single unit of electricity. If an object has a ton of electrons in it, it has a lot of electricity in it. Electricity follows this simple rule. If there are a lot of electrons in one object, and very few electrons in a different object, the electrons want to go to the place with fewer. Why electrons behave this way is very complicated, so I won't go into it now, but it's a simple rule of physics, just like gravity. So if we connect the low charge and high charge objects together with a conductive material like copper, the electrons will flow from one to the other. The process of electrons moving across this wire is what we call electrical current. Now, if we run this electrical current through certain types of materials, they can make it glow or heat up or make things move. So with this basic concept, electricity can light a light bulb or turn a motor or operate the tiny little switches that make computers work. So the question is, how do we get electricity where we want it? So we know that copper is a conductor, which will allow electrons to move through it, but other materials like rubber will not allow the electrons to travel through them. These materials are known as insulators. With conductors and insulators, we have everything that we need to make a battery. This is what the inside of a battery might look like. In this battery, the blue section is a material with very few electrons, while the red is the part with a ton of electrons. The reason the electrons aren't flowing is because they're separated by an insulator. That's everything you see in brown. The electrons have no way of knowing that there's this desirable, low electron material nearby. Now the gray part is the conductor. If we use some conductive wire to connect the front conductor to the back conductor, the electrons have a path to get to where they want. So if we want to power, say, a light bulb and a flashlight, all we have to do is make part of that path composed of the filament of the light bulb. As the electrons run through the filament, it glows and is amplified by the bulb, which means the flashlight is now on. Making an on and off switch for the flashlight is simple. We make a small part of the conductive path that the electrons take removable. When you flip the switch off, the conductive path is broken and the flow stops. When we flip it on, it continues. The switch is simply completing the circuit from the front of the battery to the back of it. This on and off switch here is the fundamental principle behind how all buttons, switches, touchscreens, and really anything electronic and interactive functions. Let's take a look at what happens when you press a button on a Game Boy. Just like with the flashlight, the internal circuitry of the Game Boy has these incomplete circuits in it, and they're completed when you push the button down. It's arranged in a way so that when this circuit is completed, it sends the electrical signal to the CPU of the system, where the flip-flop switches are changed and the thinking process occurs. This is how all inputs into all computer systems work, at least in some fashion, by completing circuits which send electricity to certain nodes in the CPU, which it understands as whatever it's programmed to understand. Touch screens use this same system by using the oils in your fingers to complete circuits which lie just under the screen. When those circuits are completed and current flows through them, the computer knows that that part of the screen is being touched. While the basic concept of completing a circuit is more or less universal to the process, there are a ton of different methods used to accomplish this, and of how to achieve the desired results afterwards. Other topics related to circuitry include things like resistors, capacitors, and Boolean logic. If you have any interest in these topics, you can let me know in the comments, and as always, liking and subscribing and sharing are a massive help.